Okay, so we have here, we have an SUV of we're doing F15-5. We have an SUV, it's got a mass of 2,500 kilograms, and it's towing a trailer of 1,500 kilograms. It says the traction force developed at the wheels is FD equals 9 kilonewton. Okay, remember that's the force that the wheels are applying, okay? And there's a traction force between the wheels and the road, which is actually the force that is accelerating the vehicle. Determine the speed of the truck in 20 seconds, so there's time information. We want to find the speed of the truck starting from rest, so V1 is 0. Also determine the tension developed in the coupling, okay? There's the coupling at A. It's the towing force here between the SUV and the trailer. Neglect the mass of the wheels. Okay, let me just get some space here. All right, so guys, the first thing you want to see here is that we have a system of particles. It's a system of particles. There are more than one particle in the system, and we are trying to find what the velocity is of the vehicle. So what we can do is we can define this as our system. Our system now contains two particles. The coupling force between the truck and the trailer is now internal. So these forces in here, the force that the truck is pulling the trailer with, and the force that the trailer is resisting the truck with, these are equal and opposite internal forces. And because we've defined our system like that, these internal forces cancel out, which mean internal impulses here cancel out. So the only external force is this FD, okay? So if we've got this mv1 plus the sum of all the impulses, okay, equals mv2, right? That's our linear impulse momentum equation. Recall that here we need the sum of all the masses at state 1 and the sum of all the masses at state 2, okay? Now this, again, remember that here that force is only an external force. We only consider forces that are external to the system as forces that will cause an impulse. It's similar with work. When you've got a system of particles, the only force that will do work is an external force. Okay, internal forces will cancel out, so the work will cancel out. So that's the same idea here. So the sum of the mass here will be 1,500 plus, sorry, I messed that one up. So it'll be 1,500 plus 2,500, which is 4,000. That's the total mass of the system, right? Times V1, which is 0, plus FD, which is a constant, so we can bring it out of the equation, FD, and it will be multiplied by 20 seconds, okay, because it is the only external force acting on the system, is equal to 4,000, did I get that right? Yes, times V2, and we're looking for V2. We know that V1 was 0, so that falls away, so that's 0 plus 9,000 times 20, so there's my force times time is 4,000 times V2, and if you solve for V2, it is equal to, let me have a look here, this is 15.5, 45 meters per second. Now, because this is a rigid link here, it's a rigid link, the two masses, the two vehicles move at the same speed, same acceleration, everything, because it's a rigid link, okay? So this entire system is moving at 45 meters per second. meaning the vehicle and the trailer are moving at the same speed because of this rigid link. All right, so now that's question 1, which was calculate the velocity of the car at 20 seconds of the truck. The second one is, what is the, let's call it the tension in the coupling. Okay, so if we draw, now guys, now we change our system. You can choose the trailer as your system, or you can choose the truck. So let's call this trailer, let's call this truck. Draw the free body diagrams for the trailer, just in the X direction. For the trailer, the only force acting in the X direction is the tension from the truck onto the trailer. Okay? Then for the truck, the forces acting on the truck will be this force here from the trailer onto the truck. Remember, these are equal and opposite forces. And there will be the traction force. So there's my one system, there's another system. Initially I chose both in my system, then these two forces cancelled out. But now if I isolate only one of the vehicles, then this is what I get. Okay? So which one would you choose in order to determine this tension? The answer is both of them would work, but I would choose this one because I've got one less force to worry about. So let's choose this trailer and let's apply the principle of impulse and momentum to just the trailer. Okay, so now this becomes my system. Okay, and so now T is external. Let me redraw this. This becomes my system, and so T is now the only external force. Okay, so we've got mv1, we're only considering the trailer now, guys, plus the sum of F dt is mv2, only for the trailer. So you can notice here, now this mass is the mass of the trailer, which is 1500 times v1, and now we're looking for the impulse due to this tension, and we know that it's a constant because why? Because this force was a constant, we can assume that this force would be a constant. Okay, so we've got T times 20 seconds, right, that's the impulse, is equal to the mass times what now? This V2, remember, both the trailer and the truck were going at this 45. So times 45 seconds. And if you solve for T, you get 3.375 kilonewton. Okay? You can do exactly the same thing if you take the truck as your system. You would then get 0 plus Fd times 20 minus T times 20 is 2,500 times V2. And this we know, so that would be 9,000 times 20 minus 20T is 2,500 V2. And V2 is 45. V2 is 45 meters per second, and T will give you the exact same answer. Okay? Cool, cheers.